function in X. Before we look at its graph, can you guess the domain of this function? Domain is the set of values X can take. The domain will be all X greater than or equal to 0, as even roots cannot have negative numbers under them. Now let's draw its graph. As the domain is greater than or equal to 0, we just try out non-negative values of X. When X is 0, root of X will also be 0. 0, 0 will be our first point. What is Y when X is 1? Root of 1 is also 1. So 1, 1 is another point. When X is 2, Y will be square root of 2, which equals 1.414. Somewhere here. This is how the graph will look. It is not a straight line as the function is not linear. Interesting. What if I negate this function now? What will the graph of minus root x look like? The first thing we should do before plotting a graph is examine the domain. As x lies under the square root, it has to be non-negative. The domain again will be all x greater than or equal to 0. Try substituting different non-negative values of x and plot this function's graph. Okay, I'm sure most of you guys would have got the correct graph. When x is 0, y will also be 0. This will be one of the points. When x is 1, y will be minus 1. 1, minus 1 will be another point. And when x is 2, y will equal minus 1.414. This is an approximate graph of the function y is equal to minus root x. What do you notice? This graph is a reflection of the graph of the original function, and it is a reflection about the x-axis. Negating the function reflects it about the x-axis. Okay, good. But what if we negate just the input? Say the function is y is equal to root of minus x. Find the domain first and then try plotting its graph. The domain is interesting here. The value under an even root cannot be negative, so minus x cannot be negative. For minus x to be non-negative, x has to be a non-positive. That's because the negative of a negative number will be positive. So the domain here will be all x less than or equal to 0. Now let's plot the graph by substituting a few non-positive numbers in place of x. When x is 0, y as well is 0. When x is minus 1, y will be root of minus 1. That will be 1. When x is minus 2, y will be 1.414. This will be the graph of the third function. Compare it to the original one. It's reflected about the y-axis. All this is so easy, but can get complicated if you don't understand how graphs are drawn. Let's summarize what we saw in this session. If y is equal to f of x is the original function, then the graph of y equal to minus f of x will reflect about the x-axis. And the graph of y equal to f of minus x will reflect about the y-axis.